All right, welcome back to Rustacean Station, where I've been in a headlock for 19 weeks now.
And I'm just now willing to let him come up for air to record another episode before he has to go back down. We are going to do the Rust 188 release, which came out in June of 2025. And first big thing in Rust 188 is let chains. This is something I've wanted so many times.
Mm-hmm. Well, now you have it.
Now
it's here. Only now. No one talks about it now.
It's pretty great.
It's pretty great. So, let chains. Anyway, so if you, in Rust, right, patterns, destructuring, say if you come from Python, here's the idea of being able to write, A, comma, B equals some tuple. And it kind of just like breaks apart the tuple and puts like the first element in A, second one in B, right? And so in Rust it's the same thing. You have like let A, comma, B equals some tuple. It just creates new variables named A and B. But in Rust, patterns can be used all over the place. But this one specific kind of pattern where I'm taking, the binding variables to some other thing, destructuring this in this way, can only be done using a basic let, if the pattern is irrefutable. In other words, if the pattern could never possibly fail. And so think about it in terms of match statements, where if you were match on a tuple, and then like you wrote like, A, comma, B inside, there'd be only one arm. And so you hear irrefutable pattern, just think, okay, a match with this pattern would be a single arm match statement, right? And so what do you do if you actually want to introduce new variables into a scope using a pattern that isn't irrefutable, that is a refutable pattern? And so Rust has always had this thing lifted with credit from Swift, where they call it guardlet, I believe. In Rust, we call it iflet, with the idea being, hey, we just use the if keyword in front of the let. And then that makes it possible to use a refutable pattern in order to bind some new variables. And if the pattern does not bind, then there's also an else branch, and you can handle it there. Or you can just make a normal if. You just fall off the end and then continue. And as long as you aren't trying to use those variables after the if, it's totally fine. It's also the opposite as well, where nowadays, I think this exists at this point in time, right? We have let else, or is that later on?
Let else is before this.
So let else is kind of the polar opposite of if let, with the idea being that with if let, I want to attempt to bind this thing, and if I succeed, I want to enter the block and run some code inside this inner block. Let else is, okay, this must succeed, and if it doesn't, I want to run some code which must return from the function or diverge in some way, and then otherwise put those variables just into my scope, right? And so kind of let else is like if let if you didn't need to increase the level of nesting. And so, but there have been some ergonomic restraints with the idea of if let in the past, where let's say that you have an option and then you need to you only want to actually bind it, or you want to do something, right? Only if the thing inside the option satisfies some predicate, say, right? And so in the past you would need to do if let sum foo equals your option, and then inside of that if do another if, right? And this is this pattern is encapsulated or expressed normally in C-like languages as just letting you do the logical and short circuit operator. So ampersand, right? Where if you think about it, like say in C or in any other C-like language, anytime that you write if foo ampersand bar, that's exactly the same as if you had written if foo open brace next line if bar open brace, right? So you're just testing a thing.
This is the case in Rust too. Like if we ignore lets.
Yes, and so people wanted to be able to do this exact same thing where, hey, I want short circuiting, where I only want some code or some piece of code to run, and then if that returns successfully, I want the next piece to go. I don't want to have to nest ifs to do it, because it should be like I might have 10 to 15, whatever, right? Conditions involved, and I want to be able to refer to variables defined via this if let. And so now if let brings, you can use the if let construct to bring a new variable into scope, inside of the condition of an if, and then refer to it in later conditions. And if any of them fail, it just short circuits like a normal if statement and then goes to your else or goes up to the end of the if block, right? And so it's very natural. It feels very good to use. So.
Yeah. And I think, the one of the reasons why it took so long to get this kind of chaining when you have let to be part of the chain, because you've been able to chain things that didn't have let for ages, right? You could always say if foo and like and bar, that worked in Rust fine. It's the combination of let with any other conditional, including other lets. So if you want to do if let, some x equals foo and let some y equals bar, that has the same, that's the same kind of thing that's been added now. But one of the reasons we didn't have it before is because, as Ben said, you end up introducing bindings in the pattern that now end up valid for the rest of the conditional, and the body of the if, right? So if I say, if let some x equals foo, well, then now I need to be able to refer to x in the remainder of the conditional and in the body of the if, because that's what I'm matching for, is to pull that x out. But that, the fact that it needed to now be valid both in the body and in the tail of the condition is where it gets tricky. Especially if you bind things in the pattern, that then have to be dropped in the condition as well. Like the drop order gets a little weird when you have, these iflets, or rather it turns out that it gets a little weird when they first implemented it. And so this is why you'll see in the 2024 edition, there's actually been a change to the drop rules and the scope rules for if let. And it was specifically changed to allow let chains to have reasonable behavior when it comes to the sort of temporary scope it ends up creating and the drop order consequences that it has.
Yes. And as a result, this let chains feature only exists on the new edition.
Yeah. And it's something where I think they thought that was pretty unfortunate. Like I think the hope was when we get let chains, hopefully we get it in all editions. And it just, I think at least so far, we haven't found a way to do that.
Yeah. Drop order is pretty subtle. And so you kind of just don't want to risk doing something differently. I think it's not even that like, it's actually interesting. The idea being that, if you introduce a temporary, when temporaries get dropped is always kind of, an interesting thing, because the idea of temporaries we don't usually think about. And often temporaries, it doesn't matter because they don't have a destructor in any way. And so it turns out that like, if you have a match, the most natural thing is to drop them at the end of the match, if it's in the condition of the match, right? And the scrutiny of the match, as they say. But if it's in an if, it is the natural thing to, stop it at the end of the given arm of the if. And so if I say if foo, I want foo to be dropped before I get to the else of, the if, right? And so it turned out that the old scoping, involved match-like semantics where it got to the very end of the overall block, and the new semantics are shorter. So we'll get into this more in a future episode, a bonus episode, talking all about the new edition that we glossed over. A future past episode.
It might be because we haven't recorded the 2024 bonus episode yet.
Or have we?
We might, or have we? But people might have heard it before they hear this one, depending on the magic that we do with
we have a wobbly, timey-wimey.
That's right. The next thing in Rust 188 is naked functions, which sounds entirely inappropriate. What are naked functions for, Ben?
I think we've spoken about this at length in the past, and so we don't need to go too deep today. But the idea being that what is a function, right? It's a lie. It's a huge lie. At the end of the day, there's no function. There's just like call instructions inside of your, your assembly inside of your CPU. And before you can, call a subroutine such a way, you might be required, very often are, to put certain values into memory where like, hey, the arguments in this function are going to live right here in these registers. And hey, I want to set up the return register to be right here. So when you're done, put it right here. Thank you. And then also, here's the return address. Jump to this after you're done. And so there's a lot of like, it's like a pretty rote
pomp and circumstance.
There's some busy work involved with actually calling a function. And then like once you're in the function, you have some more stuff to do.
Bureaucracy.
Functional bureaucracy that you don't ever think about if you're just writing code. Because it's very rare for you to need to think about it. Generally, functions are pretty well settled. The idea of like, what is a function? What does it mean to call a function and be called as a function? But sometimes it does matter. And so if you don't think you need this, you definitely don't. But the idea being that like, we call this the prologue of a function, right? Or the kind of maybe even the epilogue. You have the logic, the things inside of your function. Like if you write 2 + 2. Right. There's more instructions generated in the assembly than just, adding 2 together, right? Adding, 4 or whatever. And so, but if you actually want your function to literally just contain literally just what you wrote inside of it, there's this new naked function support. And so a naked function is a new attribute. It's required to be unsafe. This unsafe naked attribute. And then the body of the function can only be, an inline assembly. And so this says, hey, like I want to be able to have a typical Rust symbol. It is named like a Rust symbol. I can import it. It gets mangled, all the normal stuff. But whenever you generate code for this, make sure it only contains the assembly that I say. And then I don't want any of the other junk that is normally involved with defining a Rust function, because I'm doing things like interrupt handlers or some other nonsense, very low-level stuff that is typically...
Yeah, this tends to be like embedded stuff, OS level scheduling, driving interrupts where it really matters you control every assembly instruction.
Yes. So if you really need low level control over every single assembly instruction inside of a function, use naked. Otherwise, you can safely ignore it and just kind of giggle at the name.
The next thing we have is Boolean configuration. So this is for the CFG predicates, so you can add in attributes for us, where you can say, or not just attributes, there's also the config macro that lets you conditionally compile code. And there's a whole language, a predicate language for expressing what you can put inside of config, where you can check for things like, not just, is this, are you on this architecture or this platform, or have, pointers that are this wide? But you can also use some Boolean logic in there. Like you can use all and you can use any. All is a sort of helper function where all of the config predicates that are sort of the comma separated arguments to all must all be true, or any where any of them are true. And then there's not, where it is true if the thing inside is not true, like Boolean logic. But despite this being Boolean logic, one of the things it was missing was Booleans. It had no way to say true or false. Instead, you would need to do things like all with an empty argument list, which turns out is equivalent to true, and any with an empty argument list, which it turns out is equivalent to false, because any is only true if at least one of them is true. And so you needed to remember these rules that all with no arguments is true, any with no arguments is false, instead of just writing true or false. Yeah. And so in Rust 188, we can now finally write true and false in these config predicates.
Which is not often needed, but for debugging, you might want to say, hey, just turn this on just to make sure that I'm sanity checking and I'm actually enabling this code.
Yeah, it's useful for sanity checking. It can also be useful for build scripts that want to, they generate code where they're going to generate the value of a particular config attribute, and they just want to say, put true here or put false here. Could also be to easily turn on or off some giant batch, a relatively complicated configuration predicate, where you just want to do an all with a thing that's true or false.
All right. Cargo automatic cache cleaning. And so, stop me if you've never heard this before, but cargo often takes up a lot of space on your disk, right? So famously, right? So Rust has, there's, you got third-party crates kicking around. Every time that you download a new version of the compiler, it must recompile all of those and store those somewhere. And then you've got your own code, your target directory stuff, where you got like every single incrementally compiled version of all of your stuff in both debug mode and release mode. And all of this lies around forever. And kind of like, if at some point you realize I have no space left, you like run a disk utility and say, okay, it's all my Rust intermediate artifacts, and you blow it all away.
Yeah, my target directory is 400 gigabytes.
Right. So, and I think, for the target directory case, if I'm compiling this project and it gets too big, Cargo Clean will delete that. I think, in the past, though, it does not delete the things in the home directory. And so Cargo has a global sort of cache of certain things, in the home directory. And this is not typically where most of the disk usage lies. And this feature today does not touch your target directory, only your home directory. Actually, doing garbage collection in this way on target directories is still a work in progress. It's a lot of untangling the historical structure of what is target, and then like people override it and set environment variables and do all this testing. It's a very large, involved sort of process, and it's a heroic labor from ePage and Weihang Lo and all of the Cargo contributors, and it's coming along. And this is just kind of the original sort of like MVP of, okay, if we had automatic kind of routine garbage collection in Rust, in Cargo rather, what would it look like? And so, like, there are some tools that do have GC, like, so Git, for example, will occasionally, you'll do a command and you'll see, okay, pause for a second to actually run a GC pass in the background, with the idea being that, like, you know, with certain rules, it should be, reasonable for Cargo to detect whether or not an artifact has been used in the past, like, you know, several months, and, like, just do this, cleanup pass. And so we'll, in the future, hopefully, do it more for not just home directory stuff, but also for all the target intermediate builds as well.
And to get a sense for why this stuff is kind of complicated to land and takes a while, this feature actually work started on it arguably in Cargo 178, because they had to land the infrastructure in Cargo to track whether or not you were using particular files before they landed the automatic cleaning, because otherwise, when you run the automatic cleaning, you don't know whether the files have been accessed. So they waited 10 releases between when they added the metadata tracking for which files are used before they added the actual deletion on top of it, precisely so that it wouldn't end up deleting anything that maybe you actually were using just the other week.
Well, one reason they waited too was because if you happen to like jump around to different versions of Cargo, they didn't want you to be on a new version, which was then deleting all the things from your old version. Then you go back to the old version, you would have to make them all over anew from scratch. And so this kind of like slow migration is for the benefit of people who use lots of Cargo versions routinely in their development. And so
I think that brings us to stabilized APIs. One that stood out to me here was the select unpredictable function in the hint module. So the hint module, as we've talked about before with black box, is just for giving sort of optimization clues to the compiler. They are generally no ops, and the compiler is not required to do anything with them. Select unpredictable is a function that takes a bool and returns the same bool. So it's like even weirder than black box. So black box takes any t and returns the same t, whereas this is an identity function, but only for booleans. But the reason you want it is it communicates to the compiler that this boolean is you are unlikely to predict correctly. And that this prediction here applies or matters the most for the branch predictor in the CPU. So your CPU has a part in it that tries to figure out which branch is going to be taken for a particular assembly instruction based on essentially historical evidence. Like in the past, which branch have I taken? And it sort of tries to predict, well, which branch will I take in the future, so that it can start executing that branch before all the instructions before that branch point have been retired, like have actually been executed. And so it becomes sort of speculative execution that allows the CPU to more efficiently use its compute resources and its memory bandwidth. But obviously, if it predicts incorrectly, it can be very costly, because now it needs to unwind all the work that it did and then start down the other branch instead. And so usually you really want the CPU to like predict things correctly. But there are some branches that you know that the compiler or that the CPU just will not predict well. So an example of this might be in parsing numbers. If you know that on average you have like an equal number of negative and positive numbers, then the branch on whether the first character is a minus is an unpredictable branch. Like the branch predictor can't possibly do a good job of it. And so what you can do is you can use select unpredictable to give a clue to the compiler that this is the case, and it increases the likelihood that the compiler will generate branchless instructions. So some CPUs support some instructions where even though it sounds like there's a branch, you can write the assembly in such a way that that assembly instruction doesn't invoke a branch. Like it doesn't split your program into now you either need to run this sequence of operations or this other one. And you can instead represent both sequences in one more complicated command. These are more complicated commands. They're often more expensive to execute, but they are cheaper to execute than if you mispredict half of the time. And so select unpredictable can be a way to sort of steer your compiler in for this particular code if you can try to use branchless instructions. But again, only an optimization clue for the compiler.
I wanted to point out the slice as chunks method on slices here. I just call it as chunks. And so the idea being if you pass in a parameter it's a const generic parameter even, and then it will give you back a slice of arrays where every individual array is as long as the passed in const parameter, and then like a little bit on the end. And so if you have like, any remaining items in your slice that don't fit into the chunks that you're given back, those kind of just like, and if there is an exact multiple, it gives you an empty slice at the very end there. And so I think this is kind of like a neat little utility function for slices.
Yeah, it's also one of the most convenient ways to go from slices to arrays.
Yes.
When the arrays are much smaller than the slice.
And when you know arrays do have const known size. And so, in this case, right, it's funny, right? So the condition or the contract of the function is it panics if n is 0, but like this is a const generic panic. And so either it'll panic at compile time or it'll never panic at runtime.
Yep. We also got an impl of default for pointer types, and this
for the raw pointer type.
For the raw pointer type.
And so now they just give you
this upset Ben a little.
I don't know. So like right. So now if you happen to use a raw const or raw mute in any kind of like defaultable struct, that struct will now be allowed to implement default. And the default values for raw pointers are, as you might expect, null. Right. And so, it's a matter of like, it's more convenient people working with raw pointers, but also it's like, it's a little bit easier to accidentally introduce a null in some cases.
Yeah. Because previously, I guess you basically have to explicitly write std pointer null somewhere.
Yeah.
We also got extract if for hash maps. So in 187, we were talking about how we got extract if for vectors, and now we have it for hash maps as well, where it will give you an iterator over the items for which the closure passed to extract if returned true, and those items will also be removed from the hash map. So it's sort of like a retain, but one that also gives you the items that get removed. The other thing that was stabilized here were a bunch of metadata methods on proc macro spans. So previously, when you had a proc macro span in Rust, you couldn't really get very much information out of it from the compiler. This is one of the reasons why we've had the proc macro 2 crate, which gives you a bunch more information out of these, but because it's an external crate, is allowed to make breaking changes. But now the span type that comes in the proc macro part of the standard library will also include information like line, column, start and end of the file, which previously you couldn't really get to. So these spans, all you could really do with them was, I think you could debug print them, but you couldn't actually get this information out. And so instead you would use the proc macro 2 crate. But now that we have them, you can do more things with just bog standard proc macros.
Like that gives you not just the file, but also the file the expansion is in. And so the file where the macro is defined and the file where it actually gets used.
Yep.
Those are different things.
Among the other changes in 188, one of the interesting ones to me was that we have destabilized the bench attribute. So bench is, it's not really used very much anymore, in part because it's now a hard error. Specifically because it used to be a future incompatibility lint that got turned from a warning into a hard error in like, I think 177 maybe, or 178. The bench attribute was a way to write a function kind of like a test, but instead of writing test, you wrote bench, and Cargo came with this little benchmarking harness that would run that function many, many times, and sort of try to dynamically figure out how many times to run it, and then print statistics about the execution time of that particular function. It never got stabilized. Like, it always required nightly to make use of, but to actually run, but the attribute itself you could use on stable. And now that is just not available on stable at all, in part because, and the sort of underlying reason why bench never really got stabilized in the first place, was because it wasn't clear what bench should actually do, like what lies within the responsibility of bench. Things like statistical analysis of the runtime to figure out, how many times you need to run it in order for there to be enough confidence that you're willing to print the result. And this is where now we have better crates for this, like Criterion, that will actually do the sort of statistical measurement and everything. And just the bench attribute ended up being sort of too simple to be useful, but also not complicated enough to, but also like not valuable on its own. And so it never really got the love it needed, and now it's fully destabilized. The other thing that I saw in the detailed release notes is that, for Cargo, when you run Cargo test, there is a -- no capture argument you can give to tests to have Cargo not buffer the output of running your test suite. This is technically a Rust feature, not a Cargo feature, because it is an argument that gets added to the binary that gets built from your test. So this is why you have to, it's not Cargo test -- no capture. It's Cargo test -- space -- no capture, because it's an argument passed to the test binary. And that argument, that no capture argument, is written no capture with no dashes. So it's -- no capture in one word. And now in 188, you can now pass that argument as -- no capture to align to align with the way that most command line arguments are written.
It feels good to finally have the dash in there.
Yep. And I guess technically there was a target demotion as well. So i686 PC Windows GNU has been demoted to tier 2. There was a blog post that we'll link to here as well for why that happened. But apparently this is like not a thing that's very widely used. And so they were like, there's no point. It doesn't really make sense for this to get all the benefits of tier 1.
And that's it for 1.88, I believe.
Yeah, we're on to 189. 189 is a pretty chunky release. It came out in August, and the first thing here is explicitly inferred arguments to const generics. The setup here is that if you have, for example, an array, and that array obviously has a length, and you don't want to write out what that length is because it's implied by the type. So this could either be, it's implied by the return type of a function, or it's implied by the type of a variable that you're assigning it into. In those cases, you are now allowed to give underscore as the value for the const generic, in much the same way that you can, in other places, use underscore to tell the compiler, just infer what this type should be. You can now do the same for the const argument of a type. You cannot use it in places where you're not allowed to do the inference. Like, for example, in type signatures for functions, you cannot put, for example, an underscore in place of the length of an array in the return type, because the compiler has no way to, I mean, it could infer it from the body of the function, but Rust doesn't generally do inference in that way. So it doesn't, the signature of a function does not get inferred. It has to be fully written out. Same thing, you can't write, for example, returns a hash map of underscore to underscore, and the compiler just sort of fills it out with whatever you happen to return, is also not valid in Rust. So the inferred const generics follows this, or inferred const arguments follows the same rule.
This next one is the mismatched lifetime syntaxes lint. And so this one was a little bit confusing when we first upgraded to the new version, I remember, because it's somewhat, yeah, I understand the point of this lint, right? Because it is trying to tell you something about how you use lifetimes in signatures. And it was kind of pointing out an inconsistency that was very easy to kind of fall into, with the idea being that, so in Rust, in earlier versions of Rust, I mean, very early, pre 1.0 versions of Rust, lifetimes were always everywhere, right? And so there was no like hiding from lifetimes. They would find you and they would get you. And then at some point in like 2014 or so, before 1.0, people were like, hey, it's a big pain to have to type out lifetimes literally everywhere. We could use some simple rules to codify the patterns people most seem to fall into, and what we call elision, right? The idea being that there's a set number of patterns that allow us to completely elide the lifetimes in certain cases, as in not type them at all, maybe not even indicate that a type in a signature even has a lifetime. And this allows you to like remove between like 80% or more of all lifetimes in like all Rust code. And so a very important feature, but there's kind of multiple levels to it, right? So there's elision, but maybe you've also seen elision being kind of like there's no lifetime involved at all. You don't see any lifetime in the code. But there's also inference. And so lifetime inferences, if you've seen kind of like the tick, the apostrophe underscore. Right. And so, hey, like, this is you saying, I want to please infer a lifetime appropriate for this thing. If you don't really feel like typing it out, sometimes it's totally fine for the compiler to say, yeah, I got you. I can fill this in for you.
I think the rule for tick underscore is usually give me a distinct lifetime for this thing that is separate from any other lifetime.
Yeah. And so, and then there's also fully explicit where it's kind of like, hey, I am naming this, and I am, defining it, declaring it up front, and attaching it to every single place I use it. And so this new lint, is just about making sure that you don't have items from multiple categories in the same signature, because it was potentially confusing to have some types with elided, sometimes with inferred, and some types with like nothing, I guess.
I think it's one step stronger than that. So the original lint that they're leaning on here is in the Rust 2018 idioms lint group, which I actually used to just have on by default in all my projects. So I was like surprised that they've relaxed this, because I haven't seen it, because I've forced it on everywhere. The thing they were going for was that if you have a function that returns a type where that type is has a lifetime, they want to make sure that you write that it has a lifetime in there, just to make it clear to readers of the API, this type actually borrows from your input in some way. Because if you allowed inference and elision, then that type would it would look like it was an owned type with no lifetime constraints. And only when you like clicked into the type would you realize. And so they want you to like write something in the function signature to visually indicate there's actually an elided lifetime here. But they want to do so in such a way that it doesn't require that you put it everywhere. And so hence where they aligned into this sort of group concept of, let's sort of categorize, inference and elision into these different groups, and then make sure that if you mix and match them, you have to, we're going to warn you about it so that you don't end up presenting things that, when the user reads the signature, they will sort of naturally conclude that, for example, there were no lifetimes in the return type, when actually there are. And I actually recommend that people read the part of the release blog post here that talks about this because it goes into what these groups are a little bit more and gives some examples. It's also worth pointing out that the goal here is to make this even finer grained over time so that you don't get forced into, like, there's still some cases where you're going to get forced into putting a lifetime annotation where you don't really feel like you need to, or maybe some places where ideally you would put one, but the compiler is not going to make you. But I think the starting point here, like the goal they're after has a lot of merit of trying to make sure that people are aware when the return type is tied to a lifetime.
Yeah, trying to find a balance between being explicit where necessary, but also getting out of your way when it doesn't actually add anything.
Yep.
So next up is more x86 target features. So we talked about target features a lot last time, where we're just adding more of them this time. And so, for example, AVX 512 intrinsics and new features for SHA 512, SM3, SM4. I have no idea what these even are. Do you have any idea what KL and wide KL target features are?
No, I'm not sure, but I think these are, they're like extensions to AVX 512. So they're not the same as AVX 512, which is like a set of features. These are like specific extensions that I think only certain vendors, for example, have. And so it's just now there are more names that the compiler recognizes and the corresponding intrinsic functions in std arch.
Yeah, so if you're doing SIMD stuff, there's now better support for that on stable Rust because you can now explicitly enable AVX 512 plus all of its own things you can enable.
I thought the next one is kind of interesting. So the next one is cross-compiled doctests. So previously, if you ran cargo test -doc and you were cross-compiling, so you were passing -target, some other target than your host one, then previously doctests would not be run because the assumption is the doctests are for the host platform. So if you're cross-compiling, I'm just going to not run your doctests because I, as in Rust C, know that I can't run the resulting binaries, right? So if I take my doctest, I compile it for a target architecture that's not my current one, then how could I possibly run the resulting binary? It sort of makes sense, but it was a little surprising maybe, right? That cargo test -doc -target ended up running no doctests. That's now been changed. So now, even if you pass -target some other target, it will still try to run the doctests. And this could also now result in failure because the doctest, let's say, used like that particular target is indeed something you couldn't run, but it will now run them and fail, which is sort of what you told it to do, rather than just be ignoring all the doctests that were for ignoring all the doctests. And then there's now a additional little tag you can put on so when you write doctests, you write, triple slashes, and then you write triple backticks, and then you can write tags like rust or text or ignore or no run. In that tag, you can also put ignore dash and then the name of a target to say, if I am running doctests for said target, then ignore this doctest. So that you have basically a way to opt out of this new behavior for specific doctests for specific targets.
Next up, I128 and U128 in extern C functions. And so the idea being, if you define an extern C function, a function that is designed to be called with a C-compatible ABI, generally there is a lint that fires if you attempt to use a type that isn't properly defined. Like I believe like any non-repr C struct in there, any repr Rust type, in other words, would cause this lint to fire, as well as until recently, until this release, trying to use 128-bit integers. And so this refers back to a change from last year we talked about, with the idea being that even among C compilers, they did not agree on the C ABI. Well, there's no standardized, quote-unquote, standardized ABI for C. There is kind of this ossified platform-specific ABI. But for a long time, those did not include 128-bit integers in them. And so multiple compilers were free to evolve in different ways, which is what happened. And I believe that LLVM eventually came around and said, oh no, this is our bad. We need to change our behavior. And so as a result of that, last year, the ABI for ints in this way was changed, and Rust observed that as a consumer of LLVM. This was 1.77 or so, 1.78. And so now, these types, because Rust has native support for I128 and U128 integers, they no longer trigger this lint. And so now you can just use them without having to worry.
And I think they're just defined to be equal to the int 128 from C when that's available on the platform you're targeting.
Mm-hmm.
So if you're compiling against glibc, for example, then it will basically alias to the int 128, I think, from glibc or equivalent. Now there are platforms where there is no int 128 type in C, and then the Rust one just does not necessarily align with any C type.
Good luck.
That's just good luck, have fun. This next one is sort of a pattern we've talked about in the past. Like there've been other examples of this where x86-64 Apple Darwin is now being demoted to tier 2, although tier 2 with host tools. So this implies that, so with host tools here means that it's not just tier 2 for the purposes of cross compilation, but it's also tier 2 in the sense that we expect it to come with Cargo and Rust C and the various tools that you can run locally. The reason for this is because GitHub is going to discontinue providing macOS x86-64 runners for public repositories, and Apple is planning to discontinue support for this architecture altogether. And so obviously for tier 1, as we've talked about before on the podcast, Rust requires that there's a certain set of automated tests that run in CI to make sure that that basically blocks any new Rust release from happening for tier 1 platforms if those platforms are broken. But if the runners go away, then we can't validate that automatically anymore. And so basically the Rust project cannot give tier 1 guarantees anymore. And so hence this target is being demoted to tier 2. This does not mean that it's going to just stop working, right? Like enough people still rely on this that they're expecting that, if something breaks, they will go fix it and they will hear about it. It's more that this will now be it will no longer be a proactive check that blocks new releases, and rather it'll be, if it breaks, tell us and we'll fix it kind of setup. Then we have a change to the C ABI on the WASM32 target. And this, I think we need to sort of bridge, like, why is there a C ABI on WASM32, Ben?
Okay, so for WASM, right, you've heard of it WebAssembly, right? And so it's running in a web browser. Why would I need an ABI for this? And so WebAssembly can expose, WebAssembly is not designed to not just be in a browser, it's sort of a general platform interface in theory, right? It gives you, for certain, it defines a fake sort of CPU. It's a virtual machine, right? An abstract machine as well. And says, hey, like I have these operations, and if you write, an interpreter to this spec, then anyone running WASM can run these things. And so there's also, if you want to do things that aren't just, normal math or running basic functions and then spitting out some JavaScript, by a few basic DOM manipulations, you can, there's this thing called WASI. And so if you've heard of libc, which is sort of like the system interface on Linux, WASI is the equivalent for WASM, where it defines sort of these input-output things, OS level stuff. And so largely things like, how do I read a file, etc. How do I make a network call? And so as part of this also defines an interface for having WASM modules compiled separately call each other via normal FFI using a kind of ABI. And so in, Rust, as a very early adopter of WASM, implemented this WASM32 unknown target ages and ages ago. And I believe the idea was that eventually WASM was still so new and so raw, the definition changed out from under it. It wasn't really standardized. It was kind of just like a best effort at the time. And then the standard has now changed, but because Rust didn't want to break former users, suddenly it introduced a new ABI called WASM32 WASI, possibly like with a V1 in there somewhere. I think we're on a V2 by now. With the idea being, we would have a migration period where eventually WASM32 unknown would be the real standardized ABI. And I believe the WASM, standardizers have decided this is, it is time to standardize, or it has been, written down effectively. And so agreed upon. And so it's no longer kind of wibbly wobbly up in the air. This is the ABI. And so now we can implement it. And this has been implemented as the, wasm32 unknown. And that might involve some breakage to users, but hopefully by now it's been long enough that they have, upgraded all of their underlying bits.
Yeah. And it is worth pointing out too that, the C ABI in wasm32 is already standards compliant in wasm32 WASI. It is just in the wasm32 unknown target, which is sort of the original one that Rust had, where it was sort of remained in the non-compliant version. And there's a long blog post that talks more about the details here. But one of the reasons why this hasn't been fixed already was because it required a pretty substantial change to wasm bindgen, which is obviously a tool that people in that ecosystem are using a lot. Because it turned out making wasm bindgen use the new sort of conformant or the more conformant, spec for CABI would be fairly painful. And so that's been a really long process and has been part of blocking that move. But if you're wasm32 WASI, this doesn't affect you because it's already using the newer compliant, representations. I think that takes us to stabilized APIs. The one that stuck out the most to me here were the locking operations on files. So many operating systems have this ability to lock a file on the file system. They vary quite a lot between different platforms, what it means to lock a file. But the idea is that if one process locks a file, then no other process can lock that file. And it's beyond process. It's like if you do two opens of the same file, then if one file handle locks, the other open file handle cannot lock. So it's essentially a mutex. There's also a shared version that acts more like a reader-writer lock. And the thinking is that if you lock a file, you prevent other operations like reads and writes from being able to operate with that file because they don't have the lock anymore. The reason I thought it was interesting that this was stabilized is because file locking is notoriously platform specific. Like what the exact rules are around what locking means. Does it make other system calls fail? Does it just make them block? Does it let them run normally? Like the only thing that it prevents is other people from locking, but they can actually do any operations. Does it affect future file handles or old file handles? Like there's lots of platform specific behavior here. And indeed, if you open the documentation for file lock, you'll see that this is line after line after line of, this is unspecified behavior. This is unspecified, not undefined behavior in the Rust sense, but like we don't give any guarantees.
Platform specific behavior.
Yes, exactly. Then it's just, there's a bunch of lines there that says it is unspecified whether this function returns an error or that function returns an error. So that is now here. You can use it, but just keep in mind that even though it's in the standard library, this one is sufficiently nuanced that you should be very careful, to use it correctly for
in a cross-platform way.
Yes.
I wanted to look at result flatten, which is if you have a nested result, you can turn it into a result.
Yeah.
So easy enough.
As long as the error types are the same. Yeah. And then in the detailed release notes, there were a couple of things that stuck out to me. One of them was on, ARch64 platforms. Rust now defaults to, have non-leaf frame pointers. We're not going to go too much into frame pointers by now, but, frame pointers are essentially a way to make it easier for you to get accurate back traces from your programs. Whether that is during profiling or when they crash, it's something that historically has sort of been disabled for performance reasons. But more recently on newer, architectures, that performance benefit doesn't really exist. It's just, there's only downsides to having it, to omitting them. So now Rust defaults to having them on for ARch64 because as far as they can tell, all the recommendation for ARM 64-bit processors is to use it. And so now that's on and by default, and as a result, it should also be the case that you get slightly better or more reliable backtraces on AH64. I'll link in the show notes both the link to that MR and also to a description of the sort of return of frame pointers. The other that I thought was interesting is there's the format args macro that is the thing that sort of under the hood is used for print, eprint, write, and format. And the format args macro previously was just like, I mean, it existed, you could call it, but you couldn't do anything with its return type. You couldn't assign it to a variable, for slightly magical reasons. But now in Rust 189, if you really want to, you can now take the output of a format args and store it in a variable and then print it or then format it, which can be useful if you're planning to, for example, print it to multiple files or write it to multiple outputs, but only do the work to do the formatting once. So that's nice. And it's pretty nuanced why you couldn't do this before. It has to do with something called superlets, that we don't have yet, but the compiler gets to make use of the standard library. So now you get to basically cache the string interpolation.
Yeah, this is from Mara Boss, who for the past few years has been on a quest to improve formatting.
Yep.
There's a great blog post from her about reducing the size of the format object. Have you seen that one?
Yeah, I've seen that one. I think that's unrelated to this one.
Mm-hmm.
But also very neat.
I'm not sure if it's a future, I think it landed, I'm not sure in which version though. We should definitely figure out which one and then put it in the show notes.
And then the last bit I had from the detailed release notes was, there was a Ruststock change where if you now open Ruststock on mobile, the sidebar will now be full width when you open it, which makes a whole lot more sense because on mobile, having a sidebar that's not the full width of the phone is just very hard to navigate. So it's a nice quality of life improvement there where it just makes me happy how much work is going into the user experience of Ruststock overall. I think that's all I had for 189. Did you have anything else, Ben?
No, that's it.
So then we're on to Rust 190, which came out in September of 2025. And one of the headline features of this release is that LLD is now the default linker on x86-64 unknown Linux GNU. What is LLD, Ben?
What is LLD? It's LD with an L on the front.
Great. That tells me everything I need to know.
Mm-hmm. Well, it's like LLVM, where it's a low-level virtual machine, right? And so, I guess L is low-level D. So anyway, a linker, takes your object files and turns them into executable effectively, and then, lets you kind of like just bundles it together. And so historically, the linker is provided for many interesting reasons. You don't normally invoke a linker directly. Your compiler does that for you. And so you say, hey, compiler, please compile this stuff. And your compiler say, oh, this is a binary. After I'm done compiling it, I'm going to link it up for you using my platform linker. It's got the one. It's the platform linker. And so, overriding it is often strange and, roundabout. I think like in the past, like if you've ever like seen like, oh, we need to install GCC to compile Rust code, it's probably because you need GCC to find the linker for your platform, because the only cross-platform way of figuring out what linker is a platform linker involves like invoking GCC and asking. As far as I understand, it's rather arcane. And so and historically, LD, which is the basic, I'm not sure if it's a GNU thing or just a Unix thing. It's the basic linker. And it's not especially fast. It's definitely not parallel. It doesn't actually try to link things in parallel. And there's a whole new generation. I say new, but like the first one doing this was Gold, which came out like 15 or more years ago, maybe even 20 years ago. And there's LLD as well. So LLD is the LD equivalent from LLVM, which is, again, fairly parallel. And then there's also Mold and Wild, And so I think Mold and Wild are both written by individuals, not like, organizations, kind of people who are like really into linkers. You got to be a certain breed to really want to dig into these. I've tried looking at this, and it's so ill documented, like how a linker operates and all the various obscure things that you need to do to support everything. And so LLD, as the kind of first party linker from LLVM, is pretty easy for Rust to ship because Rust already ships LLVM. And so unlike something like Mold or Wild, doesn't involve changing the build process, doesn't involve adding in lots of code from new authors. It's just a matter of, hey, we could just like ship this and use this because they're probably already shipping it. I'm not sure if it's even like worth turning it off, in the LLVM version that gets distributed. So it's a matter of, hey, is it faster? And it turns out it is pretty fast. So if many builds, especially builds for small artifacts or, faster builds, right, are often dominated by linking time. And so
doc tests as well, because every doc test is a binary, just like every integration test is a binary.
And so there can be some significant improvements to using LLD as opposed to LD. And so there's been a long-standing open bug because LLD also the linkers are subtle, and if something goes wrong, you got to figure out what's the debug it, and then it goes totally crazy if you don't do it right. And also a matter of, okay, well, how does Rust expose the option to change the linker, and how do you change it back if it's wrong? And what platforms is it mature enough on to turn it on for, and what platforms is it actually fast enough? And so I'm not sure if I think Windows is fast enough, or maybe it's Mac or something where, because for the moment, it's just a matter of on Linux. And just x86 64 Linux, not even any other architecture. It's like, hey, we think that LLD is mature enough on this platform, and we think that we have sufficiently solved the problem of adding new compiler flags to Rusty. There's 2 new flags to give you a linker flavor and some other thing as well.
Yeah, basically allow you to configure the linker so that there is a thing we can standardize that is the configuration for selecting LLD.
Yeah, there's one flag to say what flavor you want, then different flag to say, hey, please use the version of LLD bundled with the compiler and not the one on the system if it exists, etc. And so it was a whole long process of figuring out the actual correct way to expose how to allow the user to override a linker.
And you could even imagine that part of the story here is if you want to stabilize switching the linker, you also need to stabilize the way to opt out of that linker. Mm-hmm. That's the reason why we need flags.
Because LLD was trying to be kind of a drop-in replacement for LD. But I can tell you by experience it is not perfectly, because there's something called linker scripts, or at least I'm sure there's more than just this, right? But linker scripts are a way that you can kind of customize the behavior of your linker, or the way that the linker will eventually process your object files. And I think what LLD tries to be compatible with LD, but there's definitely some places where it is not equivalent. And so I'm not sure what Mold and Wild do. I'm hoping they just don't bother. That's my, you know what? Linker scripts are so arcane and strange. If you need them, I'm not, disparaging you. I do pity you though.
Yeah.
So.
Yeah. I mean, the linker script ends up being put this stuff in this part of the resulting binary. Just separate from the work you're doing as a linker, just also do these things to the bits in the binary at the end. And I mean, you can do some very magical things as a result, but it's very arcane magic.
In any case, this is a long-standing compiler performance request, and so it's finally landed. And then trumpets sound and angels sing, and we finally get it's fixed forever, right? So Rust compiler performance, it's solved.
Yep.
Permanent.
I also looked at, so there's a website called perf.rustline.org, which shows you the comparison of the number, basically the time spent of the compiler to build various projects. And if you look at the delta for before and after just this LLD change landed, everything sped up. And some of the builds for especially binary benchmarks, ripgrep, for example, the incremental build for ripgrep sped up by 61%.
Yeah. So again,
because so much of it is just linking the final byte.
Incremental builds especially, because they involve very little of the Rust C side or even the LLVM side. It's a matter of, hey, we need to regenerate one file, which is the whole point of incremental builds, is you don't need to rebuild the entire thing. But even then, if you don't have an incremental linker, you need to still relink literally everything every time.
And even for a full build of ripgrep, it sped it up by 21%.
And I say incremental linker, but I believe LLD actually isn't quote unquote incremental. It's just parallel. It's just a very fast, the entire it still does all the work as before, but it just does in parallel. And so I believe that mold and wild actually are. Or I think wild is not currently incremental, but has plans to be incremental. And right now it's just very fast. So
yeah, and it is interesting too, because the issue the PR that switches using LLD by default has a lot of really good background on this change and on the ecosystem impact, but it also talks about some of the open questions they had about making a change like this, because they do have some documented cases of behavior where LD and LLD is different, like they produce different binaries. And so towards the end of it, they have a list of unresolved questions throughout this journey. And one of them is changing the linker a breaking change? There are, in hopefully very rare cases, breakages of existing code that, should probably only affect the final linked artifact. So it should be easy, and it should be easy to opt out, but it is technically breaking. There's also some interesting questions around, well, now the linker is no longer single threaded, so it's using more of your cores, but LLD doesn't respect the job server flags. And so if you tell Cargo to only use so many cores, then LLD will not respect that flag. Is that a problem? The fact that the runtime impact of compilation has changed, because there's now a shorter step but uses more cores and slightly more memory. Is that a problem? And I think these are interesting questions. I don't think we need to solve them on the podcast, but it was fascinating to read through. This next one is one I think a lot of people have been excited about, which is that Cargo has added native support for workspace publishing. So if you now have a Cargo workspace, you can run cargo publish -- workspace, and it will automatically publish all of the crates in the workspace in the right order. So by following the dependencies between them. And this is something where we had third-party binaries that allowed you to do this, that would basically, use Cargo as a library to figure out the dependency chain between your workspace things and then publish them one after the other. But that's now just built directly into Cargo. And one of the reasons why it's valuable for this to be built into Cargo as opposed to an external tool is that now Cargo can, Cargo does a test build when you run Cargo publish, where it does a build as if you had no Cargo configuration to basically check that it will build on other people's computer. And now it can do that. So when it publishes crate number 2 in the list, it can do that as if the first one was already published, because it gets to futz around with its own internal data structures. And so that verification now becomes better. It's worth noting though that a workspace publish is not atomic. So if, for example, you have 5 crates in the workspace and it publishes the first 3, and then, your internet connection goes out or something and it starts failing, the first 3 will still be published. It's not an all or nothing. And I think that brings us on to stabilized APIs, because the motion of, x86, 64, Apple Darwin is just sort of repeated in here, which it technically happened right in between 189 and 190. But that means in 190 is the first release where it is demoted. In 189, it's the announcement that it will be demoted.
Mm-hmm. So among stabilized APIs, very curious. And so there's these on unsigned integers. There are now subtraction methods that allow you to pass in signed integers and for checked, overflowing, saturating, and wrapping variants of subtraction. It's a very specific new APIs.
Yeah, and I mean, it's interesting because we've had signed addition for unsigned integers
since 1.66, I believe.
But now we have signed subtraction, and I don't know why subtraction wasn't that in the first case.
There's lots of places where if nobody asks for it, it just never happens. So you've got to, if you something that you want, don't assume it's not there for a reason. There could be a very good reason. Keep your options open, but it might also just be that no one's ever asked for this or like proven that there's a need for it.
Yep. I think in terms of actual like detailed release notes, where the main one I saw was actually related to the Homeder change again. Like this has now been, they keep being follow-ups to it where, they made a change where if the home environment variable is set on Linux, but it is empty, then ignore it and instead use the fallback way to determine the home directory. And I think the reason this came up here was because the Homeder function was deprecated, so no one really cared to look at it and no one was using it. And then they decided to undeprecate it, and now you need to like go fix it up in these other ways. But what's fascinating to me is like this is also an example of changing its behavior.
Mm-hmm.
So why the previous arguments for why, they deprecated the old one instead of fixing it, for some reason don't apply now. And I think it's because it just got undeprecated, right? So they're sort of tagging it on to the same, well, we're changing it now while we're undeprecating it, logic.
Yeah. This is saying that it would have always led to an error because it would create an empty path, which is just an error.
Yeah.
So,
well, but it adds a slash and then it adds whatever string you gave. So I feel like it might still, if you concatenated the Homeder with something,
mm-hmm.
I think you might still end up with something weird. I don't know. But I mean, it still seems like a very reasonable fix to me.
Yeah, in the universe of const stable APIs, we now have many more things on floats, and so floor, seal, trunk, frat, round ties even on both F32 and F64. So more const stuff on floats. Good to see.
And I think that's actually all that I have. Like it feels like this was, the LLD thing is really the big thing in 190 and the workspace publishing. And then the rest was just sort of ongoing, the language getting better, but nothing sort of deeply, changed in the language itself in 190 as far as I can tell. I think that brings us to the end.
That's it. Can you please, get off my back now, release this chokehold on?
I feel like I probably don't need to hold you until we do 191. Cool. Well, we will see you all when we tackle 191 next. And until then, do some jumping jacks.
Mm-hmm.
And eat a pancake.
Eat a pancake and jumping jacks.
Perfect.
All right.
Bye.
All right.